Introducing myself, I currently work as a senior data scientist at Gramener. Topic of today is predicting urban heat islands in Calgary. So this is the effort which we made to understand what is urban heat island, how we can understand the different driving factors for the same. So generally, the phenomenon that urban heat island talks about is the temperature of the city is is higher than the periphery of the city. What we observed was Calgary has grown 6 to 7 degrees warmer from 2014 to 2019. This is just land surface temperature images which are grabbed for the month of August in different years. These three types of parameters have different variables, and it has its own meanings. You can go across like different acronyms that are presented here, but in general, like we are looking at vegetation covers, surface water bodies, how the surface reflects the solar energy. um, what is the urban expansion status? For that we used Shannon's entropy as one of the indices. uh, that particular area is agglomerated or dispersed one. What is the building count in that particular area, and so on. 30-meter Landsat satellite images, infrastructure datasets, and population datasets. We did primary data pre-processing and processing just to calculate these particular indices: LST, NDVI, NDBI, urban morphological characters. So if there are some buildings, we wanted to know how many buildings are there in that particular area. The dataset which is coming from Landsat is into the similar projection. This is just plotting and listing the particular files which are present. Now, as I mentioned to you, like there are a lot of files from 2013 to 2020. You can go on the link which I have mentioned to you just to download these datasets. Otherwise, you can go on Stack API as well as Earth Explorer to download these particular images. One of the major parameters that we took into consideration is having this all wouldn't help us at all. So we went with whatever that is available at mean and max just to understand the data well. This is in general correlation plot, which does not make sense directly because we are having all of these variables together. There will be another correlation plot which will come later on, just to make you understand how each and every parameter is relating to each other. The result you can see just like this. So whatever the data sets that I showed you in the TIFF format are coming across like with respect to each and every community. We tried to aggregate all of these information, like what is the name of the community, as what is the land surface temperature that it has got for each and every individual year, and how it is spanning across. You can also see the variability and how these particular parts are getting high temperature towards 2020. So this is in general flow of identifying the communities, identifying the different parameters, environmental building structures, as well as demographic parameters, to understand how the temperature, land surface temperature can pan out, and to understand how we can predict it. Let me quickly pause here, and if there are any questions, I will take it up. Or if you want me to go to any particular slide, we'll go through it.